Okay, today we will discuss the introduction to compiler design. You know the compiler is a basic subject in computer science. Every language needs a compiler before execution of the program. So a compiler is basically a software or a program that takes one source program and convert it into the target program. Okay, and what do you mean by the source program? Means a program written in any programming language, is high level language like C, C++, Java, COBOL, etc. Okay, whatever program we have write in our high level language that need to be compiled before the execution, because we know that our language, even the English or the C, C++ could not be recognized by the computer, because you know that your computer is only can recognizes the 0-1 binary. So in order to give any instruction to the computer to do, so we need our instruction to be translated into the programming language, into the machine language. Okay. So now this is the position where the compiler lies in the programming sense. So the compiler acts as the mediator between the machine language and the high level language, because we are writing the program in the machine level language, in the high level language. High level means C program. You are writing the C program, and your program may be, say, I am writing one, say, int x, and say x is equal to say 5 that you are assigned. So these are the C programming instructions. So the computer could not understand it. That is why we need to translate it into the machine level language. So it basically, the compiler basically plays the role of a mediator between the machine language and the high level language. Okay. So what is the input and output here? The compiler has a input, whatever written in the high level language, and the output as the target program. Means the program written in the machine code for the language recognized by the machine, it is the target code. Okay. So a compiler basically bridges the gap between the high level language and the machine level language. Okay. So mainly the purpose why you are using the compiler is that computer could not understand the high level language, so we need to transform it. This one only. Now this is the overview of the language processing system. We write one program, say in the C program, and it is saved into the .C program. We do not know what is happening behind the compilation and the execution processes. Before the executable program is being ready by your system, so many things are done. So first of all, the pre-processing means suppose we have written one program, and where say one command line you have included, or you have defined, say we have defined max, say 5. We have defined one macro here, in particularly in C language. So these whatever in your program, the max keyword, the max word appears, that max to be substituted by the 5 first. Or if I write one command line that does not bear any sense to the compiler, it does not has meaning to the computer at least. Okay. So this type of programming, this type of pre-processing will be done at first. Now after pre-processing is done, your comments are being removed, or your macro has been substituted. Now the compiler takes the role that to translate the high level program into the assembly code. What is the assembly? Assembly means, say, some types of mnemonics. Some types of mnemonics, say we want to move one data, one symbolic name is their move. If we want to add few data, say we can write the add. If you want to multiply two data, we can write the multiply, and so see that these are all the mnemonics in assembly language term. So the high level language is now translated into the assembly code, set of assembly instructions, and then the assembly code can only be recognized by the assembler. Okay, you have probably you have seen the TASM or the MESM, micro assembler or turbo assembler. These are all the programs, assemblers are there, which recognizes only the assembly language codes like the move, mul or add. Okay, and then these symbolic codes will now be directly translated into the hexadecimal code so that it could be recognized easily by the computer. Now, after assembly code is generated and after the assembly code is being translated into the machine code, that code must be loaded into somewhere else in your main memory. Okay, somewhere in your main memory, and remove it and save this. Say this is your main memory, and say these are all memories are filled here, and here the code can be reloaded. Your program executable code can be loaded here. So this is called the relocatable machine code. Means wherever the free space is there, the system determines where to load the machine, code, and accordingly all instructional addresses will be set. And so this is why it is called the relocatable machine code. Now the loader and linker. Okay, what is the loader and linker? We know that in every program we need few library instructions, library functions. Like say we have used one trigonometric function, say sine, or you have used one say pow function we have used, pow with 2 parameters. Okay, we have used. So these all functions no need to define by the users, but they are all defined. Say maybe it is defined in the math.h, particularly in C language. So we have to include that. Means all the executable codes already built into the compiler, they must be linked to the system. So your program, this one, and few power function related machine codes, sin x related machine codes, all will be included into your machine code, and then it is called the actual executable code. And once it is totally linked with the library routines, now the loader plays the role that this program to be loaded into the main memory. Okay, and as per the von Neumann architecture, we know that every program should be loaded before the execution. Based on the availability of your memory, the executable code will be loaded into the memory, and then only we can say this is the process. Okay, and okay, so we have input the source program written in the high level language. If you are writing the C program, your program will be written in the .c, and after a number of stages like pre-processing, compilation, assembly, and loading and linkering, then it must be converted into the exe code. Okay, so these are all the formalities you should know, and these are happening behind the language processing. Means if you write one program and this program to be executed in a system, so we need to do that type of operations behind the programming. Now so this is the phases of compiler. So it's not like that in a single stage or single phase the total program is being processed into the machine code. So here through a number of phases the compiler works. Typically there are 6 stages, and we have already told that we are writing the source program, giving the input there in the source program. And now the typical phases are lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, and the ultimate target code generation. Okay, and then the output is the target program. Okay, so your input is the source program. Through a number of phases, a little bit transformation is being held on the source program, and ultimately we are getting the target program here. Okay, and during the analysis and synthesis of the object program, a number of tokens can be generated. Token means any meaningful word, meaningful sentence, or any information regarding your program, say regarding your identifier, regarding the values, initial values, their types, their initial values, and so on. All these informations should be stored into a data structure which is called the symbol table. And particularly there will be, we know that to R is the human, means while you are writing the program many errors can occur. So there must be separate routine for handling the errors. Not like that once the error occurs the next subsequent stages could not be performed. It is not like that. Once the error is detected, it will guess how the error can be detected, how the error can be recovered, or where the error has been occurred, and so on. Many other information will be gathered, and it must be given to the error handler. They will be managing the errors, how it can be detected, where it is detected, how it can be detected, and a clue about how to solve the error, and so on. So these are all the typical stages through which a source program is converted into the target program. Okay. Now we will discuss one by one the different phases. Okay. First of all, the lexic analysis. As the name suggests, it identifies a number of lexemes here. So what is the lexeme? Lexeme means any meaningful pattern or meaningful smallest meaningful part of the program is known as the lexeme. So lexic analyzer reads the source program. Suppose you have written one instruction here, integer x. Okay, this one. So the lexic analyzer, what it does, it starts from the beginning of the text and goes up to the end of the instruction. So this is the end. Now starts from the left side, goes to the right hand side, and goes through all the characters and tries to find out the meaningful word, meaningful token. Select here int is a we know that int is a keyword here, data type here, but separately, individually, I could not bear any meaning, n does not bear any meaning, and t does not bear any meaning. So that but if we take the word int, it bears the sense that it represents the integers. Okay, it represents the integer means, and then we have got one blank space here. While we write the C program, there is one blank space, and whenever there is blank space, it identifies that this word int is a complete lexeme here. Okay, now after the blank space, another reading will be started from the x, and immediately we can find that another symbol is appears here. So once, and in C language we know that this is the another token. Okay, this is the termination symbol, and what is x? X is the identifier here. So we have got one int, we have got another lexeme as the x, we have got another lexeme as the semicolon. So there are three. That means this is the number 1 token, number 2, and this is the semicolon is the number 3. And take the example here, say new value is equal to old value plus 12. Okay, by analyzing, by reading the token, reading the characters from left to right, and lexic analyzer recognizes that. So new value and then the semicolon or the assignment type of operator appears, means we have completed, we have got one pattern here. Basically this is a pattern matching. So tokens will be the new value here, this is an identifier, and then the assignment operator equal sign will be considered the assignment operator, then old value and then plus. So plus, we know that this is an operator in the C language at least, and the plus and before that old value, this is another token here. Okay, this is another identifier, and plus is the operator here. Okay, this is the plus, and 12 is a number here. Okay, so all these informations will be put into the symbol table. We have before in the previous slide we have shown that the symbol table is a data structure which keeps the information regarding all the data, all the information available into the during the program assembly or the compiling. Okay, so here we have got the typical tokens here: new value equal to old value plus and the 12 itself a number. Now come to the second phase of the compiler, which is the syntax analyzer. So syntax analyzer basically checks the syntax of the language. Syntax means grammar. As we write one English sentence here, we know that everyone has to abide by the rules of the grammar. So here also in the automata or the formal language and automata theory, we should know that one non-terminal will be producing one terminal or the non-terminal, or say A may be producing one null character here. So this is we have to abide by the rules. So this syntax analyzer basically checks whether you have written the program as per the rules of the rules defined by the grammar or not. So behind the compiler there will be one grammar. We know that different types of grammars are there as per the Noam-Chomsky hierarchy, but most common, most popular grammar which is being used in the syntax analyzer is the context-free grammar. Okay, context-free grammar has the form that in the left hand side there is only one non-terminal, but in the right hand side there may be more than one. Okay, and it may be the terminal and non-terminal, any combination of terminal and non-terminal. Okay, so that is in the right hand side, but the cardinality in the left hand side always be 1. So the syntax analyzer checks the grammar, and if the sentence is written as per the grammar, then the compiler produces a tree structure which is called the parse tree. Okay, and mind that only when there is no error into your program, that program will be translated into the parse tree, or sometimes it is called the syntax tree. Okay, so like here for the previous sentence we can find that this is the assignment is the root, so identifier and in the right hand side expression, that means one expression will be assigned to the identifier. Now what is the identifier? Identifier is a new value. Okay, new value is the identifier, and expression, how the expression could be expressed, this is the expression plus expression, because there is one plus with the an expression will be identifier, another expression in the right hand side it will be the number, and that identifier will be the old value and that number will be the 12. So we are matching new value is equal to old value plus 12. Okay, there is no error, that is why that parse tree has been generated. Okay, now underlying the syntax analyzer there will be one context-free grammar. We have already told that context-free grammar is a grammar which is used to define the syntax of a grammar, means how the sentence will be written, how the identifiers will be generated, they are all being defined by the context-free grammar. Okay, and one context-free grammar for the previous sentence it is given here as per the Bocas-Noor form. The assignment will be represented by identifier is equal to expression. Expression may be deriving the identifier, and the expression may be deriving the number also, and expression will be expressed as the expression plus expression. Okay, for simplicity we have only considered here plus sign, and there only you can use the multiplication, division and so on. So this context-free grammar actually says how to write the expression using the plus operator, means we can write here also x is equal to say y plus say 50. Okay, so the one tree will be generated like this one just like the previous one tree will be generated, assignment, then left hand side, right hand side means assignment, this will be the left hand side, this is one expression. Okay, this is another expression, this will be one identifier, this identifier will be the x, and this expression will be expression plus expression, this will be the identifier, this identifier will be y, and this will be the identifier, and this identifier will be assigned to the 50. Okay, so this is how the parse tree will be generated, and this is the role of the syntax analyzer to check whether the grammar is followed in writing the program or not. Okay, now come to the semantic analysis. Once the grammar has been checked, you have written the program as per the grammar, so then we have to find the meaning of the sentence. What does it mean? Whether which type of operation to be performed, on what type of data we have to perform, or if the operation to be performed at all on the data or not, or it has the analogy in the English language that even I write the grammatically correct word, grammatically correct sentence, that it's Ram cat, though the sentence is written as per the rules of the grammar, or it is grammatically correct if we say, but it does not bear any sense, or even it is written that just a minute. So if I write Ram eat cat, so it does not bear any sense, though the grammatically correct, but it does not bear any sense. So that is why the sentence is written new value is equal to old value plus 12. Maybe the old value is of the string type and you know that 12 is the integer type, so we cannot perform the addition on the integer to the string. So basically the semantic analyzer recognizes the meaning, underlying meaning of the sentence, and what type of operation to be performed, or whether the operation will perform at all or not. But particularly here in the instruction you are given new value is equal to old value plus 12. Here you have to check that whether first of all the type in the right hand side is matching with the type of the left hand side, whether they are compatible with respect to the equal to, assignment operator. And then you have to check that whether the type of old value and the type of 12 are matching or not. Means we know that the plus sign is generally used to perform the addition among the integer, floating point integer and so on, but not with the pointers or not with the string and integer. So if the old value is matching is with the type of the 12 or not, so that type of translation, that type of checking will be done here. Now intermediate code generation. Okay, so once your program is grammatically correct, once your meaning of the programming is clear to the compiler, then it's time to generate the code. Now we are now reaching how to generate the code. Okay, up to this all this lexical, we have discussed three phases: lexical analysis, syntax analysis and semantic analysis. Okay, so all these three constitute the analysis phase of the compiler. During these three stages we are analyzing the program but not generating the actual code. Lexical, we have seen identifying the lexemes. Syntax is checking whether the grammar is followed. Semantic, whether the meaning is clear to or not, whether the data types are compatible or not. Once they are verified, okay, then we are going to the synthesis phase. Okay, so synthesizing the target code, and towards this we are now generating the intermediate code. Intermediate code is not exactly the machine code, but before actual generating the machine code, a form of intermediate code is generated which is almost equal to the target code or the machine code. The notion, the reason behind it, that why not generating first time the target code, if the code can be optimized. We know that if the code can be optimized with respect to the time and the space, okay, number of instruction, number of variables, or the time for the execution, if everything can be considered and if they can be minimized, so before generating the actual code we are generating the intermediate form of the codes, and on the intermediate form we will perform the optimization if possible at all. Then after the optimization the code will be translated into the machine code, and the code will be now be loaded into the main memory. Any executable codes, library modules will be linked, and then it will be loaded by the loader or linker, and then the code will be executed. Okay, so a compiler produces an explicit intermediate code representing the source program. Generally that target intermediate code will be machine independent. Okay, so that your target program could be run on any system. That is why it should be independent. So that consider this example now. New value is equal to old value into fact plus 1. So ultimately after the analysis phase we have identified that this is the identifier 1 is assigned to the addition of 1 plus the multiplication of the another 2 it may be this one, the 12, the multiplication of the identifier 2 and identifier 3. Okay, so now the intermediate codes will be, so we are basically multiplying the two operators here, operands here, identifier 2 and identifier 3. 2 and 3 are multiplied here. MULT is just intermediate code, and where the data will be stored we are taking one temporary variable here, that is the temp1. Now after multiplying identifier 1 and identifier 2, now we have to add the result with the 1. So we are adding, basically add temporary 1 value with the value 1 has implies that this is the constant value 1, and whatever the output it must be stored into the temporary value 2. Now this temporary value 2 will be now loaded into the identifier 1, because we know that ultimately this result will be stored into the identifier 1. So this temp value is stored into the identifier 1. This is the temporary code. Now code optimization. What form of optimization we can perform? Go to the just previous slide here. So how many temporary codes instructions are there? There are 3 number of instructions here. Okay. So first of all, addition, multiplication result is stored into the temporary 1, and the addition is done into the temporary 2, and then temporary 2 is stored into the identifier 1. So instead of the move operation, the third instruction can be reduced by just storing the result, the addition of the temporary 1 and the constant value 12 here, and can be directly stored into the identifier 1, so that this statement, this third instruction, can no longer be needed. Okay, so these two identifiers is multiplied and stored into the temporary 1, and the temporary 1 is added with the constant value 12, and then it is stored into the identifier 1. So this is the code after the optimization. Now it's time to generate the actual code, object code or the target code, and say again this one you can consider it as 12 here. So the actual instruction, it depends on the assembly language instruction or the architecture of the microprocessor that in which you are going to execute your program. So here basically we have to move. We know that different registers are there into the microprocessor. Many programmable registers are there, so all data has to be stored before they are being used in the operation. So identifier 2 will first be stored into the register 1, and then multiplication can be performed with the identifier 3, and the result will be, so R1 and identifier 3 will be multiplied, and the result will be stored into the R1. Now the R1 and the constant value 12 will be added, and the result is stored into the R1 itself, and ultimately your result will be stored into the identifier. So we are issuing one move instruction here, so R1 to identifier 1. Okay? So this is the storing the identifier 2 into the register 1, and then register 1 is multiplied with the identifier 3. Now this register 1 again added with the constant value 12, and the result will be stored into the identifier 1. So we have completed all the 6 typical stages of a compiler, and now we will revisit at a glance we will see how the compilation is being done. So you consider this example here, position is equal to initial plus rate into 100. How through the different phases of the compiler the source code is being translated. So first of all, the role of the lexical analyzer, it identifies the lexemes basically. So identifier 1, so position will be considered as one of the token, and which is the identifier 1. This is the another assignment operator, it has a special meaning to assign, and this is another identifier, this is another identifier, this is one operator here, and this is the operator, is operator sign multiplication, and this is the constant value. Okay, so it basically identifying the different tokens, whether they are identifier, whether they are operators, whether they are constant value, and so on. Okay, now the syntax analyzer. So it checks whether the syntax or the grammar is followed here. Before in previous slide we have specified that how the context free grammar, CFG, context free grammar for accepting that type of sentence. We have written it that one expression may be expression plus expression may be the identifier may be the constant value, or the 12 or the 60 here also. So the output of the syntax analyzer is basically a parse tree or the syntax tree If it is error free, there is no error, so one syntax tree will be generated, and if there is an error, so that error will be reported to the error handling routine. Another routine is there which will be dealing with the errors. And at the same time, whenever you are creating one identifier and its initial value, its type, everything will be mentioned into the symbol table. Okay. And now the semantic analyzer, it finds the meaning of the sentence, what type of operation we have to do, and before that whether the operation could be performed at all, means whether the data types are compatible with respect to the operator or not. As we here want to perform the multiplication on the identifier 3 and the 60, so before that we have to assure that identifier 3 will be of the 60 type or the 60 must be of the identifier type. Okay, so the 60 has not defined explicitly the type, but the identifier somewhere else we have defined the identifier. Maybe we have defined the identifier as the say float. Float ID3 means here the rate. So we have somewhere in your program we have defined the float rate, means the identifier 3 is defined as the real time data. So that is why before multiplication, so the 60 constant value 60 to be translated into the real type. So one operation is performed here into real, one function or typecasting is performed, then the type will be compatible with respect to the multiplication, means identifier 3 is the floating real type and 60 is being translated into the real type. So two real will be now multiplied, and let we assume that identifier 2 and identifier 1 they are all defined as the floating point type also. Okay, now the intermediate code generation. So first of all, the 60 will be translated converted into the real value. Let it the temporary 1 is the temporary variable. Now this temp 1 will be multiplied with the identifier 3 and stored into the variable identifier temporary 2, and temporary 2 will be added with the identifier 2 so that the result will be stored into another variable, that is temporary 3, and ultimately the temporary 3 will be stored into the identifier 1. Okay, so this is the intermediate code, and if possible we can optimize it. We can optimize here. We can directly write, instead of the first instruction we can directly write here temporary 1 will be assigned to the identifier 3 into 60.0. Sometimes we have done in the C programming also. If you are going to divide one floating point with one integer value, we know that the floating point result will be omitted, but we will get only the integer part of this result. So if you want to get the floating point also, do not want to miss the floating point part, so you can write here 2.0, so that both type will be compatible, both are going to the floating point type, so the result will be in the floating point also. So first of all the typecasting is done explicitly here, implicitly here 60.0, and then the addition is performed and it is stored into the, so instead of the 4 instructions here, so we can perform the programming task here only with the 2 instructions. Okay, now go to the final code generation. So what are the particular mnemonics? These are called the mnemonics in assembly language class. These are called the mnemonics, means assembly language instruction we need to know about the mnemonics or assembly instructions. Select move F, floating point data we are moving from the identifier 3 to R2, and then we are multiplying the floating point data with the 60 and the data stored into the R2, and then moving the identifier 2 into the R1 and adding 2 floating point data at add if R1 comma R2, and the R1 will be now stored into the identifier 1. Okay. This one. So now these are the questions that may arise, that you will be given as that given the instruction. Okay, So how this code will be translated into the machine code? So using all the phases, starting from the lexical analysis, what the output of the lexical analysis be means the identifying the different tokens here. It could be the identifier 1 is equal to identifier 2 plus identifier 3 divided by the constant value 10, means the lexical analysis is over. Now syntax analysis, it performs the grammar checking and then draws the parse tree. Okay, so one parse tree will be generated like this. Okay, and this will be now this one plus and this one as per the grammar. The parse tree will be generated, and now the intermediate code will be generated just like the previous one. And after generating intermediate code, actual mnemonics will be generated in the assembly language, and if possible then the optimization will be performed. And the next question is differentiate the syntax analysis and the semantic analysis. Okay? So syntax analysis is particularly the checking of the grammar, and semantic analysis is about the finding the meaning of the sentence, whether it does bear any meaning or not. So that is the semantic analysis. And the next question is why the lexical analysis and syntax analysis are kept in separate phases of a compilation. You know that the lexical analysis performs the identification of the lexemes, and so in order to identify the different types of lexemes, we need to know the regular expressions, and we know that the machine format for the regular expression is the finite automata. It may be the deterministic or non-deterministic, maybe the two types, you know, the DFA or the NFA, non-deterministic finite automata. So underlying the lexical analysis, there will be one regular expression, and the regular expression will be executed by the finite automata. Okay, so this is the lexical analysis. And on contrary, the syntax analysis basically checks the grammar, whether the grammar is followed in writing your program or not. And we have already informed that the context-free grammar plays a role in defining the rules of the grammar. Means how one identifier could be written, or how the different types of operators could be used in your program in writing the arithmetic expressions. Say you have written one So if I write only this production rule in the context-free grammar, this is one of the production rules in the context-free grammar. If I write only the grammar as expression is equal to expression plus expression, then we are bound to use only the plus operators. Okay, and so context-free grammar, and we know that the underlying the context-free grammar, there will be one machine format which is called the push-down automata. So the push-down automata is the machine format which will recognize whether your grammar is followed in writing the program or not. So in nutshell, a compiler is a program which translates the source program written in any high level language and convert it into the machine level program. And what is the position of this compiler? We are writing the high level language, and we know that the machine can only recognize the machine code. Okay, so we need a transformation from high level language to the machine code, and that transformation is made by the compiler or interpreter. Both are called the language processor, but we learning here the compiler. We know that the compiler, there is a slight difference between the compiler and interpreter. Interpreter checks the line by line, while the compiler checks the whole lines and generates all the error reportings, and the whole program is translated into the machine code if there is no such error. And not that in a single stage the compiler works or the whole program is translated into the machine code. It works in a number of phases. Typically there are 6 phases, starting from the lexical analysis, starting from the lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, target code generation. Okay. These are all the 6 pages, and we need to study the concept of the automata theory also here, because we need to define the rules of the grammar. That is why we need the context-free grammar here. And in order to design the lexical analysis, the identification of the lexemes needs the knowledge of the regular expression also. So we need the regular expression, regular grammar, and the finite automata also. Thank you.